Hi, hopefully you just watched a video on how we get this formula right here, what it's used for and where it's coming from. This is how we get the derivative of an inverse function, and in this video we're going to explore how to specifically apply this at a point. So here's the problem I'm going to give you. If we're given f of 2 is equal to 3 and the derivative at 2 is 3/5, what we want to know is what's the derivative of the inverse of f at 3. Now, this can seem a little confusing, so what I do is I often make a chart, and I take my function and I organize my function's information on one side. So I know my function is f of 2 equals 3, and I know my derivative at 2 equals 3/5. And then I look at my inverse. Now, if you have a function in the inverse, remember if you have an a, b for your function, the x and y's are switched and you're going to end up with b comma a, because all of your x and y's are switched, and inverse is a reflection of the function about the line y equals x. So if I know that f of 2 equals 3, that means that f inverse of 3 equals 2. And if I have f inverse at 3, I can find the derivative of the inverse at 3, but I don't know what that is, and that's what we're looking for. So the goal is to figure out what this is. I would highly recommend organizing this information into a chart because it's going to make using this formula a lot easier. So let's grab this formula and supply it to what we just did. So I've moved my formula over here. What I want is I want f inverse, the derivative of that, at 3, and that's going to equal 1 over f prime of f inverse at x. So f inverse, and our x is 3 in this case. I'm going to plug it in there, and now I'm going to go ahead and start substituting things. We know that f inverse at 3 is equal to 2. So I'm going to rewrite that with a 2. So that's going to equal 1 over f prime of 2. And if I look and see what's f prime of 2, I've got that right here. F prime of 2 is 3/5. So I'm going to substitute that 1 over 3/5. And if we multiply by the reciprocal, we get 5/3. So this is the answer to the derivative of the inverse at 3. Alright, so we've got our answer. So this question mark should be replaced with a 5/3. Now, here's where it's really important to go and look at some patterns here. If you have a function and you take the derivative at a specific point, if you switch the x and y values, the derivative of the inverse function at the xy switch is going to be the reciprocal. So these are always going to be reciprocals, but you've got to be really careful. The 2 and 3 don't match. Remember, we have to do the swap as indicated up here with the inverses. So let's look at what that means graphically. If we look at that graphically, and I believe I have an image I want, here we go. What I have graphed here is this h of x is 2 times e to the x, and my f of x is the natural log of the quantity x over 2, and as you can see, they are reflected about the line y equals x. They look like really nice inverses. We have a lovely point right here on my first graph at 0, 2, and we have a lovely point here, 2, 0, and you can see that fits what we just talked about with inverse functions. The x and y's will be switched. Now, what I've done is I've created the equation of the tangent line for this graph, and I'm going to plot that, and you can see that it goes through that point. And if I plot the equation through the tangent of the other graph, I get 2 lines that intersect at my y equals x, and if you look at the slopes of these 2 lines, they have to be reciprocals because of this intersection point. And you can actually do that analytically and figure out what the slopes of those lines are. If you look over here at my graphs, you can see the slope is 2 for one of them and the other slope is 1/2. Okay? So there's a graphical representation of what we just talked about. I hope that helps illustrate what's going on. This is an important concept to know and understand, and if you understand where the derivation comes from of this formula that we discussed, it's going to be a lot easier to remember.